Good morning to all. I am Geeta, Assistant Professor from ECE Department, Rohini College of Engineering and Technology. I am going to handle the subject on Communication Engineering. So now I am going to discuss about the topic on error correction and error detection capabilities of Hamming codes. So on completion of error detection and error correction capabilities of Hamming codes, the students will be able to define error correction, define error detection. So here the detecting double errors, that is d minimum will be less than greater than or equal to 2 plus 1, that is d minimum will be greater than or equal to 3. For correcting up one error, that is single error, that is d minimum will be greater than or equal to 2 of 1 plus 1, that is d minimum will be greater than or equal to 3. So then encoder of 7,4 Hamming code. So the figure shows that the encoder of 7,4 Hamming code, that is the encoder is implemented for generator matrix. So the lower register contain check bits C1, C2 and C3. So these bits are obtained from the message bits by mode 2 addition. So the mode 2 additions operation is nothing but XOR operation. So here we have to see this diagram for the encoder for 7,4 Hamming codes or 7,4 linear block codes. So here down we are having check bit, in up we are having message bit. So the input bit sequence will be given to the message register. Finally we will get the code word as the output. So the switch S is connected to message register. First all the messages are transmitted. The switch is then connected to the check bit register and the check bit are transmitted. This form a block of 7 bits. This bit are taken for next block. So then syndrome encoding. So syndrome encoding means let the transmitted code vector x and the corresponding received code vector is represented by y. So then we have to write x is equal to y if there is no transmission errors and x not equal to y. If there are errors created during transmission, then the decoder will be deduct and correct the errors in the y by using the stored bit pattern in the decoder about the particular code word. So for longer block length, more and more bits are required to be stored in the decoder. So we know that every n, k linear block code there exists a parity clad matrix H of size H q cross n. So H is equal to P transpose colon IQ, the size of Q cross n. So the transpose of the above matrix can be obtained by interchanging the rows and columns, that is H transpose will be equal to P and IQ, the size of n cross q. Here the P is the submatrix of size K cross Q and IQ is the identity matrix of size Q cross Q. So we have to define the P submatrix in earlier that the transpose of parity check matrix H transpose is a very important properties as follows. The X into H transpose will be equal to 0, 0, 0 and so on 0, where H of size 1 cross n or H transpose of size n cross q will be equal to 0, 0, 0 and so on 0 into 1 cross q. So in that way we have to calculate the error. So in this way the error will be equally corrected and deducted. So this method will be mainly depends on the error pattern only. It does not depend on the particular message. So the syndrome vector S is the size of 1 cross q. Thus q bit of syndrome can only represent 2 power q syndrome vectors. Each syndrome vector is corresponding to particular error pattern. So in that way we have to calculate the syndrome vector, that is S is equal to y into H transpose. The quiz question is based on error detection and correction capabilities of Hamming codes. Is the final code after encoding data bits 1101 into 7-bit even parity Hamming code is dash. Thank you.